The bicycle consists of several main components including the frame, wheels, pedals, chain, and seat assembly. Each component was modeled individually and then assembled to create a fully functional mechanical system. The design focuses on stability, smooth motion transmission, and realistic mechanical proportions. Here we can see the complete bicycle assembly inside SolidWorks. The model includes multiple parts connected using assembly mates to ensure correct positioning and motion constraints. The assembly allows realistic movement between rotating components such as the wheels and pedal mechanism. A motion study was performed to simulate how the bicycle operates during use. When rotational motion is applied to the pedals, power is transferred through the crank and chain mechanism to the rear wheel. This exploded view animation illustrates the assembly process of the bicycle. Each component is separated to clearly show its position and relationship with surrounding parts. The animation helps visualize how the bicycle can be assembled step by step and improves understanding of the mechanical structure. A stress analysis was conducted on the bicycle frame to evaluate structural strength under loading conditions. Forces representing rider weight were applied to critical areas of the frame. The simulation results display stress distribution using color mapping, where blue represents low stress and red indicates higher stress regions. The results show that the frame maintains safe stress levels within acceptable material limits. Photorealistic rendering was applied to enhance visualization of the final design.